Good afternoon, everyone. Today we're going to start chapter 5. Are there any questions over chapter 3 or 4? If nobody has any questions, then we'll move on. All right, chapter 5. We're going to deal with logarithms and exponents. They're inverses of each other. They work in conjunction with each other, so that's why they're together in one chapter. The first half of this chapter deals with the properties of exponents. That's what we're going to cover today. On Monday, we're going to finish the chapter by looking at the logarithms and all the properties thereof. So we have to first start off by talking about composition of functions. What this composition means is a function within a function. And eventually you'll get to know these, that you'll refer to other students as the Fogg and Goff technique. So what this is really saying is this: if we had two functions and they're written this way, you can expand it to represent this. If you add the two functions together, then do the x, or you can add the individual functions together first. The same thing with subtraction. So this is f of g minus g of x, f of x, I'm sorry, f of x minus g of x. It works with multiplication and division as well. F of x times g of x. And f over g of x is f of x over g of x. So it's whatever operations inside this parenthesis, that's what you separate the two. Whatever comes first goes first or on top. Whatever comes second goes second or on the bottom. Now, for the rational one, the bottom one, the last one we have, there is a stipulation. G of x cannot equal 0. All right, so let's take an example of this. Let's say f of x equaled 2x plus 5, and g of x equals 3x squared. Let's look at all four of these. F plus g, f minus g, and f times g, f divided by g. So what the first one says here, we can either add the two functions together first. We can go 2x plus 5 plus 3x squared before we plug in the value of x. Or we could look at them separately. and which is where we got the f plus g of x. And this one equals 3x squared plus 2x plus 5. And the second one, we have the f of x minus g of x, which is 2x plus 5 minus 3x squared. Whenever you deal with subtraction or negative signs, always put your equations in parentheses to separate them, because this negative sign changes anything behind it. So this becomes 2x plus 5 minus 3x squared, which equals negative 3x squared plus 2x plus 5. In the third one, we have 2x plus 5 times 3x squared. This is just distributivity. 3 times 2 is 6. X squared times x is x cubed. Plus 3 times 5 is 15. X squared. And the last one is 2x plus 5 over 3x squared. Okay, so that's how you set them up. Let's look at what the properties really tell us. F plus g of 2. We're using the same f and g. The only thing different now is I gave x a definitive number. Which means it can be expanded as f of 2 plus g of 2. F of 2 simply means anywhere I see an x in the f function, I put a 2 in its place. Same thing with a g. Anywhere I see an x, I put a 2 in its place. So I'll work them out separately. The first equation, 2 times 2 is 4, plus 5. Order of operations in the second one, do the exponent first. So it's 3, 2 squared is 4. Notice I'm treating both of them separately because they're separated by a plus. They're two different equations. 4 plus 5 is 9. 3 times 4 is 12. 9 plus 12 is 21. Because another way, we could have added to the equations together first. We could add the two functions together first. We could have done it this way. 2x plus 5 plus 3x squared, which gives us 3x squared plus 2x plus 5 when x is 2. So anywhere I see an x, I put a 2 in its place. 3, 2 squared plus 2 times 2 plus 5. 2 squared is 4, so it's 3 times 4. 2 times 2 is 4. 12 plus 4 plus 5. 16 plus 5 is 21. Which side looks easier?
The first side.
Yeah, the first one, the right-hand side. If you do them both separately and add the answers together. Let's do the subtraction aspect of it. So if you're going to use the right-hand side, what you can do here, you can find both of these equations separately. This is 2x plus 5. This is 3x squared. So when x is 2, I put 2 in place of x and work them out. Is 9. 3 times 4 is 12. Once you do it this way, once you find these two values, all you have to do is plug in those values. Since f went first, it's 9 minus, and g of x is 12. 12 is bigger than 9, it's negative. 12 minus 9 is 3, so the answer is negative 3. Okay. We know what the values of f of 2 and g of 2 are, so all I got to do is put the values in. 9 times 12, 108. So the f is on top, so that's 9. G is on the bottom, so that's 12. They both have a 3 in common. And those are your solutions. So if you want to, you can always just find the specific values of the f and g or however many functions you have and just plug in the values. All right. Let's look at some of these. All right, so the first equation. This is, notice how, okay, in chapter 5, the first section is chapter 2, section 3, because we skipped that earlier because this part goes better with this unit. So it's 2.3. Yeah, it's true. So y'all didn't skip it, okay? That's what called compositions of functions. So it says let f of x, this is chapter 2, section 3, question 1. Let f of x is 4x minus 1, and g of x equals x squared minus 4. Find f of g of negative 5. Okay. Now, this doesn't look like anything we've done just a minute ago. This is that little O in the middle is short because you read this f of g. That's how you would read that. So here's our first example. Chapter 2, section 3, chapter number 1. F of x equals 4x minus 1. G of x is that. It's giving us find f of g. So whenever you see this little circle, this O here, that really means of. F of g equals that, which means f of g of -5. Remember, in this one, we read that as f of x. So whatever comes first is on the outside, whatever's next comes on the inside. So in this equation, you could do the same thing we just did earlier. Let's find f at -5. Let's find g of -5. Well, so we just need g of -5. We don't need that just yet. So g of -5 is -5 squared minus 4. 5 squared is 25 minus 4 is 21. So g of -5 is 21. That goes on the inside. So now we have that. So now we have to find f of 21, which is 4x minus 1. Anywhere you see an x, put a 21. 4 times 21 minus 1. 4 times 21 is 84 minus 1 is 83. So the final answer of this equation is 83. So you build the equation down. Let's look at the next one. We have f of x is equal to 2x plus 1. H of x is x cubed. We're asked to find h of f of 1. So we're supposed to find h of f of 1, which, remember, again, this means h of f of 1. So the first thing we have to find is f of 1 from 2x plus 1. So 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. So since f of 1 is equal to 3, that goes inside the parentheses. Now we go to the h function. We have h of 3 is x cubed. So anywhere we see an x, we put a 3. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. Okay, let's look at the next one, number 3. 2.33 says given f of x equals 4x plus 1 and g of x equals x squared minus 4x minus 5, find Goff at 4. Remember, Goff, G of F is the same thing as G of F of 4. So you have to first find F of 4, and then whatever that is, you find in G. So F of 4 is 4x plus 1. Anywhere I see an x, I put a 4. 4 times 4 plus 1. 16 plus 1 is 17. So this 17 goes inside the parentheses. So we have G of 17. The G function is x squared minus 4x minus 5. So my x is 17. These people are cruel. 7 squared, 4 times 17. So 17 squared 9 is 289, 289, right? Yeah. 4 times 17 is 68 minus 5. 289 minus 68 is 221. Minus 5 is 216. So that's your final answer. All right, let's look at the next one. Number 4. This is 2.3.4. Given h of x is x to the 5th. Find h of x. Okay, notice for the same function. So what this means is h of x. So what is h of x? H of x is x to the 5th. Again, h of x is x to the 5th, but whatever we have inside here goes in place of the x. So we have x to the 5th, that's my x, to the 5th. But this is h of x. Whatever we put inside here, we put inside there. Since we put x to the 5th inside there, that means it goes there. We'll see later on that whenever you have power to a power, you multiply. So the answer is x to the 25th. Which, again, I don't know why they gave you a property that we haven't discussed yet. So yeah, whenever you have a composite function of itself, you take whatever that is and put it back inside itself. The next one, number 5. 2.3.5 says, find f of g, fog, of x, and Goff, and the domain of each of this. F of x is x plus 13. G of x is x minus 13. And then the domain. So we have two things to do here. We have the fog and we have the Goff. So this is the same as f of g of x. Next one is g of f of x. What is g of x? G of x is x minus 13. So f of x is x plus 13, but g of x is x minus 13. So I replace it with that. Now, anywhere I see an x in my other equation, I put whatever g of x is. So this is the same thing as saying f of x equals g of x plus 13. G of x is x minus 13 plus 13. They cancel. So f of x is x. And likewise is the other one. What this one's saying is I take whatever f of x is, it's x plus 13, put that inside the parenthesis. And the function g is x minus 13. So anywhere I see an x in the equation, I plug in what's inside the parentheses. So that's really f of x minus 13, which is x plus 13 minus 13. 13's cancel. What? Right here. Yeah. Okay. Yeah. That is more advisable doing that. Yeah. So whenever you plug in g of x is x minus 13, put in parentheses. F of x is x plus 13, put in parentheses, and then you can remove it afterwards. Now, this question does more than just tests our knowledge of fog and Goff. What this thing says, if f of g of x equals g of f of x, and they both equal x, then they are inverses of each other. That's the test. So if f of g of x equals g of f of x, and they both equal x, like they did here, then f and g are inverses of each other. F and g are inverses of each other. And then we have a separate symbol for that.
So how do you tell that's a math
Hmm?
So in the answer that they're asking, in the box, you just put X.
Yeah, it's x. But here it's saying, okay, so f of g equals x. Oh, it's asking for the domain. What's the domain? Yeah, so it's negative infinity, comma, infinity. Okay,
Three-part problem.
it's a three-part. Yeah, I hate when I do this. Okay, what is f of g of x? That's f of g of x. Oh my God. That's exactly what it was. Yeah, so there was actually, again, this is one of the limitations of online math. Because yes, it is f of g of x. Okay, now what's next up? This is g of f of x. So I plug whatever I have in for f, I plug inside of g. So I have, let me see, I'll show you. So what this says is f of x equals x squared minus 18. G of x equals 3x minus 6. G of f of x is g of f of x. F of x is x squared minus 18. Now in G, anywhere I see an X, yeah, I was doing the G of X because I didn't like specifically what they were asking for. If math is just, okay, what's the final answer? That's what I care about. So inside G, anywhere I see an X, I put that in there. So it's 3 times x squared minus 18 minus 6. So wherever I see an X, I put whatever's inside the parentheses. Distribute 3x squared minus 54 minus 6, 3x squared. They're both negatives. 54 plus 6 is 60. So g of f of x is 3x squared minus 60. Yeah, so you have to be very careful when you do this. So g of f of x, f goes inside the g. So basically, here's another way of looking at it, which should make it a lot easier actually. F of x is x squared minus 18. G of x is 3x minus 6. Fog is f of g of x. What that means is this. Since g is on the inside, I take that and anywhere I see an x, that's where I put the g of x. So I have 3x minus 6 squared minus 18. So f of g goes inside of f. And just the opposite of it, Goff, since that one says g of f of x. Since f is on the inside, whatever I have for my function f, I plug it in place of x in the g function. So this is Goff, this is Fog. So I have 3 times x squared minus 18 minus 6. And you work it out, of course. This should break it down in a nutshell. It's just substituting inside one equation inside another equation. Now number 7. This is 2, 3, number 7. It says for the given functions f of g of x, fog of x, and g of f of x, and the domains where f of x equals 9x plus 1, g of x equals square root of x. Find fog and Goff. Okay, we'll work these out completely and then we'll go back and plug them in so you can see how it's supposed to be plugged in, because it is very picky then. Okay, remember, fog is the G goes inside the F. That means I have f of square root of x so the g of x goes in place of x. That's the fog. So I have 9 times the square root of x plus 1. And the other one is g of f of x. That means this function, anywhere I see an x, the function f goes inside it. That's Goff. So I have g of 9x plus 1 equals the square root of 9x plus 1. Okay. Now we got those. Let's plug those in first and then see how it yells at me. So fog, we saw that was 9 square root of x plus 1. Yay. Now Goff, that was the square root of 9x plus 1. Now the domain. The only thing we have to worry about here is violating what are my limitations of x. What is the domain of square root of x? Remember the graph of square root of x, right? You cannot have negative. So x equals 0 to infinity. So that's the domain of that one, because the smallest it can equal is when x is 0, y is 0. That's the smallest a radical can equal. Now, same logic with this one, 9x plus 1. The smallest, what would make it equal to 0? If we take inside here, set it equal to 0. That's the smallest. You can't have negative. It's the smallest it could be a 0. So solve for x. X equals negative 1/9. That's the smallest it can be. So it goes from negative 1/9 all the way to infinity. You see how this, now we're starting to combine a lot of stuff we've done in the past. Okay, so the domain here, put it in interval notation. So we have a bracket, 0. Oh, that's the wrong sim. We have a bracket, 0, comma, infinity. And infinity is always parenthesis. This one is bracket, negative, we need a fraction. So it's negative 1 over 9, comma, infinity. Yeah, it's, now we know what they want. So we'll do it again. In question number 8. 2, 3, 8 says find fog and Goff and the domain of each. F of x is equal to radical x plus 15. G of x is x squared minus 15. So in the fog, we take this equation and plug it to x inside that. So we get square root of x squared minus 15, put in parentheses, plus 15. X squared minus 15 plus 15 under the square root, combine like terms. Square root of x squared. The answer is x. Square root and x squared cancel.
Plus or minus.
Well, it's just it's asking us for the domain. So it's going to be from negative infinity. Yeah, so it's plus and minus. It's going from negative infinity to positive infinity. Now for Goff, I take the f function and plug it in place of x here. This is fog, and this is Goff. So I put the equation square root of x plus 15, and I square it, minus 15. The square and the square root cancel. Combine like terms, 15s cancel. So g of x is x, which makes it negative infinity to positive infinity. Any value of x works. So what do we know about f of x and g of x? They are inverses of each other. So f of g of x is, I hate when this happens. It's the square root of x squared. Where's my square root? My square root is gone. There it is. So it's the square root of x squared.
Yeah, read the instructions.
Yeah, it's just okay. Now f of g of x. When I plug those in there, I don't know how far back it wants me to take it. So if I plug in g of x inside f of x, the 15s cancel, so I square root of x squared which is just X. Oh, crap. Yes. Its absolute value is plus or minus. Same thing here. Okay, square root of 50 is X plus 15 minus 15 is absolute value of X. Okay. The domain of f of X is negative infinity comma infinity, and same thing. Because it equals X at the end, and X could be anything.
Read a plus or minus. Squared, squared.
Okay, this issue with that one is, oops, crap. On the previous one, since f of X was X plus 15, the smallest individually, that one component, I wish you told me, okay, you have to look at both individual as well as the composition. The composition was X, so f of X and G of X was X, but they were wanting to know, okay, what are the limitations of X before you start? Before you start the thing, what are the limitations of f of X? What's the limitations of G of X? F of X, let me show you. F of X was where's my screen? Okay, there's my ladybug. I share it. There. Okay, so since we see for our final answer, f of X and G of X, they're both infinities because they're both X's. But looking back at the original one, the limitations of f of X, remember, inside here, as small as it can be is 0. So X equals negative 15. So the smallest X can be for this function is negative 15 to infinity. And G of X is X squared minus 15. It has no limitations. It goes from negative infinity to positive infinity. So even before you start doing the whole thing, the limitation of any composite function will be the smallest limitation of any of the individual pieces. Even though when we work it out, we found this is Goff and this is Fogg. They want to know is individually, what are the smallest restrictions? So on the Goff, that's the one. Okay, and the last one here, number 9. 2, 3, 9. Find f of x and g of x if h of x equals fog and h of x equals 3 over x minus 2 to the 8th. This is a rational function, so f of x is on top, g of x is on the bottom. That's one way you could do it. Or we can see that this is, oh, yeah. Yeah. So what is f of x? F of x could be 3, and g of x is x minus 2 to the 8th. Or it could be 3 over x to the 8th. That's f of x. And g of x is x minus 2. Because this individually could be. Or we can have f of x is 3 over x, and g of x is x minus 2 over 8 to the power 8. We just have to see how they decompose it. Because we have a function, how are the different ways it could be decomposed? Let's see what options they give us. F of x is x over 8 over x cubed. No. 3 over x. Okay, that's one of ours that we have. That's the last one we did. 3 over 8 x to the 8th is x. That's another possibility. Right, so A and D cannot be right. Now, what would be the most logical one? It was ideally B and C both exist. So which one is the most logical one?
This whole thing is not logical.
Well, we have to break down this function, the 3 over x minus 2 to the 8th power, break it down to its smallest constituent parts. So in other words, because remember, it has to be a composition of f of g of x. So we have to break this down. Inside here, there has to be an f of x and a g of x. Inside this function here, let me go back.
So inside the parentheses might be the G.
Right. We can have, this could be the g of x, and this whole thing could be the f of x, like we did here, 3 over x to the 8th, and g of x is x minus 2. Or we can have 3 over x, where g of x is x minus 2 to the 8th power. So the question is to find the most logical one. Well, let's look at this one. No, select all that apply. Okay. So only ones it can't be are A and D because 8's on top, and it's a 3.
Select more than one.
It can't be D. Yes, just select all that apply. It can't be D for sure because bottom is x minus 2, and that's nowhere near this. And that one's going to be wrong exponent. There's only 2 possibilities. I didn't invent this question. On a test, I would say, okay, here's a function, 3 over x minus 2 to the 8th. Decompose it. Tell me what f and g could be. And you'd come up with two different possibilities. Okay, so that's decomposition and compositions. Now, oops, 5.1. Let me see, what's my share? Ladybug. Chapter 5, Section 1. Inverse functions. So to find an inverse, first step, switch X and Y. And then solve for Y. That's the procedures. Switch your X's and Y's and solve for Y. Once you finish that equation, it is now the inverse. Your Y value is now going to have that symbol. This means inverse. So, for example, Y equals 3x plus 2. To find the inverse, first step, switch X and Y. Now solve for Y. Subtract 2 from both sides. And then divide by 3. So my inverse is X minus 2 over 3. That's why I know this is my inverse equation. This is my inverse. This is my original. Remember from section 2.3 how we test if they're inverses? Because if this was f of x and this was g of x, f of g and g of f both have to equal x. To be an inverse, we have to check both ways. So f of g, we take the g function, plug it in place of x. This is fog. So I have 3x plus 2 minus 2 over 3. I don't need the parentheses. So 2 negative 2. X's cancel. Okay, so the fog works. Now try the GOF. In the GOF, whatever the f function is, I take it and plug it anywhere I see an x in the g function. So it's 3 times x minus 2 over 3 plus 2. So first thing we do here, whenever you multiply fractions, is can anything cancel, top and bottom? Yeah, the 3's can cancel, leaving me with x minus 2 plus 2. The 2's cancel. So because they both equal x at the very end, that means they're inverses. Okay, let's say I gave you a data set let's say my data set consisted of the points 2, 3, 3, 4, 5, 7, -2, 9. Here's my data set. I'm terrible at the squiggly lines. If this is my function f, what is the inverse of x, f of x?
Scribble next to f of x.
This one? This.
Back there.
Well, that was my initial attempt at a squiggly line, at a bracket, at a squiggle bracket.
So what is, you're saying f of x is that data
Is
set?
this data set, right? Because whenever you see the squiggly lines, you know that means it's a set, and it's an answer, a set of answers. So if f of x were these 4 points, what would be the inverse? Remember the first step? What's the first step of finding the inverse? Yeah, remember in a point, x goes first then y. So the first thing to find the inverse, we switch x and y. This is f of x. This is f inverse of x. So the first point will be 3, 2. Then 4, 3. Then 7, 5. Then 9, -2. That's the inverse. Make sense? So again, the first step of finding the inverse is switch x and y. These are points. That's x, that's y. Switch them. Yx.
Why we get that much?
Okay, then what don't you get? Why do we do that? Okay, now how would you
What's gonna happen?
graph an inverse? Which points? But once you have I give you the original function, you find some points. Once you find those points, what are the points of the inverse function? Once you have these points, switch x and y. Now you have the graph of the inverse function. All right, so let's look at some questions here. Oops. Okay. Find the inverse of these points. What's the first one going to be? Let me finish writing these down real quick. Yeah. All right, so the inverse of these would be, 5, -9, switch x and y. -6 and 6. This is x, this is y. So I switch x and y. -3, -5. -5, 5. And that's all there is to finding inverses. If I gave you points, it helps us to graph them. So let me see. So it'd be parenthesis 5, -9, -6, comma 6, -3, comma -5, close parenthesis, -5, comma 5. Find an equation of the inverse relation. Five, 1, 2. If x equals y squared minus 9y. Remember, how do you find the inverse? Yeah, so first thing you have to do is swap x and y.
That's the answer.
There's your answer. Just swap x and y. So it's x squared minus 9x. Determine whether the following function is one-to-one using the definition of a one-to-one function. Okay, let me write this one down first. 5, 1, 3. F of x equals 1 over 8, x minus 7. Okay, there. So when we talk about one-to-oneness or one-to-one, basically we're asking is, does the inverse exist? If the inverse exists, then it's one-to-one. If it doesn't have an inverse, then it's not one-to-one. So okay, we start off with y equals 1 over 8x minus 7. First step, switch x and y. See if an inverse exists. First step is what? So it's solve for y now. We can add 7 to both sides. So it's x plus 7 equals 1 over 8y. Multiply, since 8's on the bottom, multiply both sides by 8. The 8's cancel, which gives us an inverse of 8x plus 7, which is 8x plus 56. And we'd have to first test if this is a true inverse. We have to plug it in there and plug it in there. But to save time, yes, it is an inverse. So let's see what the question is asking for us to find. Is it a one-to-one function? Yes. Okay, in this one, do I have everybody on the screen? Yes. In this one, it says use the horizontal line test to determine whether the function is one-to-one. Here's where we have a connection, which is terrible because I ran out of paper. Oh, I'll use this paper. Here's the connection. If an inverse exists, then the function is one-to-one. or 1 to 1. If a function is 1 to 1, then it passes the horizontal line test. Is this a first one? Is this a function?
Hmm,
Yeah, it's a function because remember, a long time ago, we talked about, is it a function? Does it pass the vertical line test? The vertical line test is it a function? Is a circle a function? No, because it passes at 2 points in the vertical line test. So this is yes, it is a function. No, it's not a function. How about a straight line? It does pass, so it is a function because it passes the vertical line test. The horizontal line test it tests for one-to-oneness. One-to-oneness means an inverse exists. So in the first one, does it pass the horizontal line test? That'd be a no because it crosses at 1.3 times. If it crosses more than once, then it's not, it does not have an inverse. So this one has no inverse. A circle, again, it fails the horizontal line test, so it has no inverse. A line, on the other hand, yes, it has an inverse. So it is a one-to-one function. So a function you can have a function, but it doesn't necessarily fit the one-to-oneness. Means you can't find an inverse for it. So let's go back to our question. Use the horizontal line test to determine is it one-to-one? Is it one-to-one? No, because if I draw a horizontal line here, I hit more than once. Use the horizontal line test. Is this one one-to-one? Yeah, because any horizontal line I look at, it doesn't hit the graph more than once. Graph the function and determine if it's one-to-one using horizontal line test. So this is 516. All right, for this one, how do we graph this one? What's the graph going to look like?
Point down. Same direction.
Right, we rearrange it. So yeah, it's a quadratic equation. It's negative, so it points down and they both point the same direction. So we got that. And what does this plus 9 do?
Left,
It doesn't,
that's the Y.
this is y-intercept. So it moves the graph up
up,
9 spaces. So then looking at this, 3 squared minus x squared, we know it's going to be 3 minus x, 3 plus x. So the x-intercepts are at positive and negative 3. And the y-intercept is at 9. So again, because we have this, we have to find the y-intercept, the x-intercepts, the direction, and the shape.
Does not pass the horizontal line.
Well, no, quadratics automatically do not pass the horizontal line test. But the graph, we know it's going to be this. It crosses at 9, so it's there. And it's a negative 3. And at positive 3. Where'd my graph go? It must have liked my graph. So is it a one-to-one function? No. No horizontal, is a function of no, because no horizontal line intersects the graph more than once. That's not it. No, because at least one horizontal, yeah, so that's that one. Now we have the cubic function. Is a cubic function one-to-one? Yeah, I don't know, could be's. What's the graph of the cube root look like? Cube root of 5x. The cube root function looks like this. So yes, it is one-to-one. So back here, yes, it is one-to-one because it doesn't cross more than once. Find the inverse function. So y equals that. X equals 3, 5y. How do I get rid of the cube root? Cube both sides. So those cancel. So we have 5y equals x cubed and divide by 5. So the inverse is x cubed over 5. Remember, you have to tell me it's the inverse by put that -1 exponent there. So it's a fraction. On top, it's x cubed. On the bottom, it's 5. Ah. Find the inverse relation of this equation. So what do y'all think? What's
Swap the x's and y's.
okay? So we're in this one. So switch the x's and y's. And then solve for y, right? First step, switch x's and y's and solve for y. So add 7 to both sides. 2y equals x plus 7 divided by 2. So my inverse is x plus 7 divided by 2. The equation of the inverse. So I have, it's a fraction. Top is x plus 7 divided by 2. I gotta put the inverse. Y inverse equals, we did that already. Oh, don't tell me you just wants this. Oop. X over 2 plus 7 over 2. That's not the equation. Well, no, okay, no, all they want here is first step, just switch x and y. That's all they wanted, but that's not really the inverse. So like for this one, all they want is x equals 4y minus 8. Oh, yep, that's nothing. That's frustrating. Yeah. So it just wants the equation of the inverse relation, not the inverse equation. That's frustrating. Okay, everybody. Since I'm out of paper, we have to call it a day there. So yeah, we'll finish up. We'll do the we did the inverses. We'll do exponential functions. Well, there are about 9 or 10 rules of exponents we have to cover first, and how to convert from exponents to other functions. And then we'll do the properties of logarithms. We'll do that on Monday. Okay, everybody. I hope that helped. And I will see everybody Monday. Have a great weekend. Stay safe. If you have any questions, just send me a message, a remind, and we can get on Zoom if you need to.
Thank you.
Thank you.
And this time, I promise, I did tape it.
Oh, okay.
All right. Thank you.